Hello, everyone, and welcome. Our project is called Project Mesh, and it's part of a broader mission at Greybox to build accessible technology for communities where internet and power are limited or unavailable. Project Mesh is an Android app that allows users to message and share files with each other over a virtual Wi-Fi based mesh network. But Wi-Fi has a limited range, just a few hundred meters. So this semester, our team, Team fLoRa, set out to explore a big question. Can we extend that range using LoRa, a low-power, long-range radio technology, without disrupting the app's existing design? Our work this semester was focused on feasibility, understanding how LoRa interacts with IP-based communication, prototyping serial communications with radios, and identifying integration pathways that won't break the existing mesh logic.
The customer discovery process has 3 steps: problem identification, hypothesis development, and customer interview. The problem for this project is finding a way to integrate LoRa with the existing implementation to extend the range and give users an offline option. Our users will be people who do not have reliable access to Wi-Fi and need to communicate over longer distances than what is provided with Wi-Fi. We drew from Greybox's mission statement and our target audience for this project to help build user stories that would shape our research direction and implementation. Initially, our focus was on researching LoRa functionality and its compatibility with Android devices and the current code implementation. Since the current code uses Meshrabia to build a mesh network over TCP with IP packets, we needed to determine if LoRa could function with TCP. Since this was quickly proved to not be the case, we then researched Meshrabia itself and alternative solutions. We discovered that Meshrabia is nicely modular, allowing for easy addition of new features, and that it may be possible to use UDP with LoRa in the existing mesh network. Our requirements now focus on smoothly integrating the new features with pre-existing code.
To evaluate how LoRa could be integrated into Project Mesh's architecture, we explored a range of supporting technologies. We began by working directly with LoRa radio modules over serial monitors. This gave us a simple way to configure and test the modules during early development. All prototyping was done in Android Studio, where we built test applications to experiment with device interaction and packet routing. We also assessed TCP and UDP as transport options. From there, we explored 3 key technologies to enable IP communication over LoRa: PPP, Tune, and TAP. Let's dive deeper into these technologies, starting with PPP. To bring IP communication to LoRa without modifying Meshrabia's internals, we turned to PPP, standing for point-to-point protocol, which seemed to be a natural fit for LoRa's UART-based interface. The diagram here shows how PPP wraps a raw IP packet with a header and trailer, giving it the structure needed to travel across a serial link. This framing enables compatibility with standard IP-based tools while introducing minimal overhead. With PPP's biggest advantage being that it works transparently with existing networking stacks, this route gave us a clean, standards-compliant way to transmit packets over LoRa.
Now let's segue to Tune and Tap. Tune and Tap are kernel virtual network devices that redirect packets. Tune is responsible for carrying IP packets, while Tap devices carry Ethernet frames. There are some noticeable drawbacks to using Tune and Tap, especially high latency due to LoRa's low bandwidth constraint. So you may be asking, why did we even use it, and how did we get around this challenge? First, Tune and Tap afford us much more control over the IP and Ethernet frames that LoRa communicates over. This grants us the flexibility and creativity to message on important internet protocols such as TCP and IP. This opens up some exciting possibilities such as sending emails, browsing the web, and sharing photos, just to name a few, all over LoRa devices. Using Tune also gives us great access to Android's versatile network APIs, making development far smoother and promising for future ventures. We have tested the performance of these methods by performing a TCP handshake over Tune, and we are excited to share our results.
To gather information about the network performance of TCP/IP over LoRa, we built a standalone test app that sends text messages between LoRa modules connected to Android phones. We give each device a virtual IP using a TUN interface so we can read and write normal IP packets. But LoRa's low bandwidth can only handle tiny packets, so we wrap up those IP packets in basic PPP frames. That gives us clear stop and start markers and CRC checks so that we could slice up big IP datagrams into bite-sized LoRa chunks and then reassemble them on the other side. We ran 2 versions of this, one using UDP and one using TCP, so we could take a look at our results. So in this demonstration, you'll see that the UDP is just magnitudes faster than TCP. The handshake and teardown alone is, devastating to LoRa's low bandwidth links. We ended up deciding that UDP is the way to go. You can even see on these charts here that UDP costs us 1 packet, where TCP costs us 6 extra packets, so 7 in total, and 5 more seconds. So.
Our work extends Project Mesh's reach to areas with little or no infrastructure, enabling long-range, low-power communication. It creates real impact, from supporting disasters response to lowering infrastructure costs. With LoRa's energy efficiency, it's also a sustainable solution. Most importantly, we've built a foundation for future teams to continue developing the system and turning research into action.
As the semester comes to a close, we found that LoRa integration and compatibility with MeshRabia is feasible. We found that UDP is far faster for sending and receiving simple messages, and we recommend this approach. While TCP may be slower, we are working on ways to improve our PPP, tune, and tap approaches to enable faster connections, including but not limited to mesh encoding and ARP messaging. All our work and research can be found in our documentation, which lays the foundation for the road ahead.
With these insights, we're ready to explore integration next semester. We know that LoRa can be used to move IP packets using UDP, so it is possible. Our next step would be to research and take a deep dive into MeshRabia to see just where and how to integrate our LoRa transport layer. If it looks feasible, then we will work on extending MeshRabia to handle LoRa links, but if it turns out to be too tangled, we're ready to sketch out alternative ways to extend Project Mesh's communication range with LoRa. Either way, we've proven a core idea this semester, and we've laid the groundwork for future development and integration.